Let's start off with a brief introduction to confirmatory factor analysis. Today, we're going to delve into a fascinating world of CFA, which is an essential technique in psychological research. Confirmatory factor analysis acts as a valuable tool akin to a detective, and it allows us to examine and validate theoretical models in psychology. But what does CFA actually do? Imagine yourself as a detective connecting clues to uncover specific conclusions. In this scenario, your theory acts as a map that links these clues, known as your indicators, to their corresponding conclusions called factors. CFA functions as a magnifying glass, and it enables you to scrutinize your map and determine its alignment with reality. Consider an example related to intelligence research. By employing CFA, a researcher analyzes indicators such as problem-solving ability and verbal comprehension and logical reasoning to assess if they measure an underlying factor known as intelligence. Through statistical techniques, CFA estimates the strength and direction of relationships between the indicators and the latent factor. And this serves as a means of verifying if a theory aligns with empirical evidence. Now, let's explore the goals of CFA. Primarily, it involves theory testing, and it ensures that the relationships between indicators and factors correspond to the observed data, like comparing a map to a city's layout. Secondly, CFA facilitates model evaluation. This enables researchers to assess if their theoretical model is practical. Lastly, CFA aids in reliability and validity assessment, and it guarantees that indicators accurately represent what they measure. By utilizing CFA, we can develop accurate guides to understand and predict psychological phenomena, which empowers us to make informed decisions in clinical settings. The process of exploratory factor analysis, EFA, can be likened to embarking on a journey into uncharted territory. You're searching for hidden landmarks or latent variables without a pre-existing map. EFA is employed when we lack clear hypotheses, like a detective without leads searching for patterns and clues. In contrast, confirmatory factor analysis verifies an existing map representing a hypothesis about the relationship between observed variables and latent variables. CFA is employed when we have a specific hypothesis to test, such as ascertaining if behaviors indicate depression. So while EFA allows us to explore and chart new territories, like being an explorer, CFA empowers us to test and confirm existing maps, adopting the role of surveyor. This distinction lies in the contrast between gathering and interpreting data as explorers and ensuring our theories align with evidence as surveyors. In the past, we've talked about parameters, which refer to distinct characteristics or attributes in psychology, and it indicates the connection between variables. Estimating these parameters involves strategies like EFA and CFA, and it's like an archaeological dig. Imagine EFA as an archaeological dig without knowing what you'll find. You're determining artifacts or parameters without specifying their era. Similarly, in psychology, EFA identifies symptoms of anxiety without pre-specifying their relationships. Conversely, CFA is like a dig with a specific goal. As a researcher, you must specify the variables that you expect to relate to factors. In neuropsychology, CFA identifies which cognitive functions might be affected by an injury and checks if the data supports your predictions. So both EFA and CFA are essential, with EFA offering flexibility to explore and CFA requiring specific hypotheses about relationships between variables and factors. Once our models have been created using either EFA or CFA, we may wonder how to evaluate them. Comparing EFA to sketching a portrait, we aim to capture the main elements and general features without being overly concerned about precise measurements. In contrast, CFA is like architectural design. It requires certain standards and measurements using fit indices like chi-square, RMSEA, and the CFI. Consider the application of EFA and CFA in clinical psych, where EFA can be used when developing an assessment tool for a mental health condition. CFA is then utilized to validate this structure in a new sample, confirming the presence of the same clusters. In forensic psychology, EFA can aid in exploring patterns in crime scene data, with CFA assessing its accuracy using new crime data. In neuropsych, EFA can be employed to investigate cognitive functions that may be improved by a drug, with CFA confirming these effects. And as demonstrated, while EFA and CFA have distinct approaches, they both serve as invaluable tools in psych research. It helps us explore and substantiate our understanding of complex phenomena. In the next video, we'll take a deeper dive into these two methods and their differences using diagrams.